An independent variable is a variable that can stand alone. So an independent variable would be the x, or the input, and dependent variable would be the y, or the output. So in science, an independent variable is what you change in an experiment, and then you check what happens to it, the situation with the dependent variable. Oftentimes time, most likely time, would be an independent variable, and cost would be a dependent variable. Slope. Slope is the formula m equals y2 minus y1 over x2 minus x1. Slope is rise over run. It's the change in y over the change in x. So there's two types of equations that we're going to learn, that we're going to work with today or in this lesson. And one is slope-intercept and one is point-slope form. So slope-intercept form is y equals mx plus b. So in slope-intercept form, the m is the slope and the b is y-intercept. Point-slope form is y minus y1 equals m times x minus x1. So your x1 and your y1 is going to be the ordered pair, and your slope is going to be m. So when you graph, the first thing that you want to do when you're graphing in slope-intercept form is start with b. So start with b, which is the y-intercept. So you start on the y-axis, and then you're going to apply the slope. And over here, you're going to plot a point. So you're going to start with x1, y1 as a point, and then you're going to apply the slope. So a couple examples down here. This first one right here is in, or multiple examples, I guess. This first one is in slope-intercept form. So my b is -1, so that's going to be on the y-axis. So I'm going to do a slope of -1 on the y-axis, or the y-intercept is -1. Then I'm going to go down 3, right 1. Okay, over here I'm going to find the point. So the point is going to be -3, +1, because the formula was y2 minus y, or y minus y1, x minus x1, so that means opposite. And then my slope is -1, because that's a number in front. So I'm going to start at the point -3, 1, which is right there, and apply the slope of -1, which is down 1, right 1. So down 1, right 1, down 1, right 1, and then I connect. So I'm going to do some more graphs with slope-intercept form. So if I have y equals 2/3 x minus 5, I'm going to start at -5 on the y-axis and go up 2, so 1, 2, and then right 3, and make another point. And then connect. Y equals 2x is actually starting at 0 and going up 2, right 1, and then I connect those. So this line's right here, this line's right here. Okay, this one, I'm going to start at 1, because that's my y-intercept, and my slope is -1, because the coefficient of -x is -1. So down 1, right 1, down 1, right 1. The second line, I'm going to start at 3 and go up 1, right 2. Okay, and the last couple, this one, I'm going to start at 2, because that's a y-intercept, and go up 1, right 1, because the coefficient of x is 1. And then the second line, I'm going to start at 3 and go down 5, right 1. Okay, here's some more examples with lines. So write an equation of a line given the slope equals 7 and the y-intercept is -5. So because I'm given the slope and the y-intercept, I'm going to use slope-intercept form, because I already have the slope and the y-intercept, because I'm given the slope and the y-intercept. So the equation is just going to be y equals 7, because that's my slope, x minus 5. Okay, in example 2, write an equation of a line passing through these 2 points. Well, I'm going to use, whenever I'm given 2 points, I'm going to use point slope form, because you're given a point and I can calculate the slope. So I'm going to calculate the slope between here and here. So it's going to be x1, y1, x2, y2, 3 minus 6 over 2 minus negative 5. So this is going to be negative 3 on the numerator and 7 in the denominator. So that's my slope. Now, when I do point slope, I can take any point. So I'm going to use this one in this slope and write it in point slope form. So it's going to be y minus 3 equals negative 3/7 times x minus 2. Because remember, you're doing the opposite for x and y. Special types of lines are horizontal and vertical lines. So I remember to use horizontal and vertical lines with HOI VUX. So the HOI stands for horizontal. So a horizontal line has, the O stands for a slope of 0, and the Y stands for, there in the equation, Y equals a number. So the VUX stands for vertical lines have a slope that's undefined, and the equation is going to be x equals a number. Okay, that's how you can keep horizontal and vertical lines straight. So if I graph x equals 4, that's going to be a vertical line. So on the x-axis, this is the x-axis, this is the y-axis. I'm going to go over 4, so over 4 units, and make a vertical line. For y equals negative 2, I'm going to go down 2 on the y-axis and make a horizontal line. So those are my 2 lines. The slope of a vertical line is undefined, because slope is rise over run, and the run is 0. Since you cannot divide by 0, the slope is undefined. So whenever you're calculating slope and you have something like 5 over 0, 0 is under 5, so if 0 is under, it's undefined. The slope of a horizontal line is 0. Example 3, write an equation of a line that's parallel and passes through this point. Find the slope by solving for y. Okay, whenever you're trying to find the slope of a line, you want to put it in slope-intercept form and solve for y. So I'm going to solve for y with 4x minus 6y equals 24. So I'm going to subtract 4x, and then I'm going to divide both sides by negative 6. So the goal of this is I want to find the slope. So this will be negative 4 plus 2/3, because 4/6 is 2/3 x. So slopes that are parallel, lines that are parallel, have the same slope. So I'm going to use 2/3, and I'm writing it in point slope form. So here is my point. So using this point and this slope, I'm going to write it in point slope form. So in point slope form, it's going to be y plus 5, because remember it's opposite, equals the slope. Slope is the same because it's parallel, and then x minus 1. So to write that in slope-intercept form, I'm going to solve for y. So it's y plus 5 equals 2/3 x minus 2/3, and then I'm going to subtract 5. So my equation is going to be y equals 2/3 x minus 5 2/3, because negative 2/3 and negative 5 is negative 5 2/3. Okay, write an equation of a line that's perpendicular. So perpendicular, your slope's going to be an opposite reciprocal. So I'm going to find the slope of this. So the slope of this line is 6. So slopes that are perpendicular are opposite in the reciprocal. So we studied that a little bit in chapter 1. So this is going to be negative 1, 6. So I'm going to take this point in this slope and write it in point slope form. So it's going to be y plus 3 equals negative 1, 6 times x minus 4. And to write it in slope intercept form, I'm going to solve for y. So it's going to be distribute this. So it's y plus 3 equals negative 1, 6x. And this will be plus 4, 6. 4, 6 is 2/3. And then I'm going to subtract 3. So my answer is going to be y equals negative 1, 6x. 2/3 minus 3 is negative 2 1/3. So perpendicular slopes are opposite reciprocals. Parallel slopes are the same. So write an equation line that's perpendicular. So I got to find the slope of this first. So I need to solve for y. So I have 2x plus 5y equals 10. So I'm going to subtract 2x and divide both sides by 5. So I'm going to get y equals 2 minus 2/5 x. So my slope is negative 2/5. So the slope that's perpendicular is going to be 5/2. Okay, so remember that's an opposite, that's a reciprocal. So I'm going to use this point that they're giving me and this slope and write it in point slope form. So point slope form is going to be y plus 1, because there's a negative 1, equals positive 5/2 times x minus 1.